This is the Web Platform Podcast, episode number 43, Modern JavaScript with ES6 and ES7. Today we have a couple of guests and a small panel yet again. We have Danny Blue.
Hey, everybody.
And myself, Eric Isaacson. And our guests today are well known in the JavaScript community, both of them, aj-oneal and Jafar Husain. So if you guys would like to introduce yourselves, Jafar.
Hi guys. My name is Jafar. I'm a tech lead at Netflix, and I'm Netflix, of course, is a member of the TC39, and I represent Netflix there among several other people. And I'm looking at forwarding some proposals around asynchronous programming into JavaScript 2016. We use quite a bit of reactive programming at Netflix, and that's what I consider my area of expertise to be.
Apologies for the butchering of your name.
No, it's fine. And
AJ?
So I am a Node and Angular developer. I love JavaScript. I follow the cult of Douglas Crockford, and I'm famous in the JavaScript community for my catchphrase, yo yo yo, coming at you live from, well, usually Provo, and that's where I'm coming at you live from today.
Insert awesome place here.
Yeah.
So there's a lot to talk about today. I hope we get most of it in there. I know most of us, especially Danny, has some very strong opinions on ECMAScript 6, which is, I guess, ES 2015 or whatever it is now.
Yes,
ES7.
That's my first opinion. Is I refuse to call it ES 2015.
Most people are in agreement with you. I think it's the committee, if I'm not mistaken, that has decided that it would be called that, right?
Yeah, I have like zero confidence that it's going to come out in 2015, stable in all browsers.
This is an absolute fantastic start.
So what is modern JavaScript? Why should we be concerned with this? What is ECMAScript 6 or whatever we're going to call it now, and ES7?
I think that it's the distillation of a lot of the, first and foremost, I think it's a distillation of a lot of the patterns that we see out in the JavaScript community, and sometimes those on the committee will refer to it as reverse refactoring, which I think if you look at a lot of the features in JavaScript, like arrow functions, destructuring, those are great examples of reverse refactoring, where we see the same pattern being used in JavaScript again and again. And I think a lot of the people out there who've been using ES6 now through transpilers like Babel are beginning to see just how much smoother and how much less boilerplate and how much clearer sometimes some of those patterns can be now with the ES6 syntax.
So with that, is it just syntactic sugar then? So like, is ES6? So like, is it just the fact that like, okay, prototypes now appear as classes, or is it more deep down than that?
Well, so first of all, I want to stand up for syntactic sugar. I think syntactic sugar is important. If we didn't think syntax was important, we'd all be using Lisp. I think that syntax is very important, and I'm a big fan of some of the syntactic affordances in JavaScript. They make a big difference for the readability of code, and of course, code is read much more often than it's written. So first and foremost, if there's an implicit premise that somehow syntactic sugar is a G, a nice little flourish, I disagree with the premise. And second of all, it is definitely more than syntactic sugar. Features like proxies, for example, tie in with ideas like the extensible web manifesto. Of course, TC39 works with other standards bodies like the WhatWG and the W3C, and there are a lot of adherents to the extensibility manifesto on the TC39. And features like so to give a précis for those who aren't aware of what that is, I think there's a large number of folks on standards bodies nowadays that think that standards bodies shouldn't be doing a lot of innovation, right? In fact, better yet, we should take practices that evolve out of the community that have been proven in userland, and then we should get involved only when standardizing those practices helps, essentially, rather than trying to run ahead and come up with standards that may be potentially useful. And so the Extensible Web Manifesto is an effort to empower developers out there to basically build features and have the same access to browser features that somebody on a standards body would, for example. So if you look at, this is outside of TC39, of course, but if you look at efforts around web components, for example, where you're basically giving developers the ability to leverage the same sort of under-the-hood access that the browser developer would get when building a control, for example. And proxy sort of falls into that, in the sense that you can now do things that magic DOM objects could only do before. For example, like you can simulate exotic objects. And the idea behind empowering users to do this is that, well, they can build a polyfill that's very, very close, if not exactly the same, as what we standardize in the future. And so it's not just syntactic sugar, it's also about opening up the platform, and I think it's part of a broader initiative to open up the platform, to give developers more power, and frankly, let us do less. And I think that's good for everyone.
There's a lot of stuff too with, like, Google gets dinged for this all the time, where some of the community feels that a lot of these proposals have kind of been forced on them and shoved down their throats, and then when they get implemented in the browsers, maybe they're implemented quickly, and then there's performance issues. Now they have to take it back, and then they put in a different version, and then they have all this ugliness in the browser that you have to support. Is that true, or is it partially true?
Well, I mean, it would have to depend on exactly what we're talking about. For one thing, implementing these features in browsers is an absolute necessity. We're not going to write up a several thousand-page spec and then go and implement a feature without getting any user feedback. The only way to do this, to get realistic user feedback, is implementing these features in browsers. And I'm not standing up for any one particular, first of all, I'm only on the TC39. I can't necessarily comment on what's been done with web components or whether that's been handled the right way, but I can tell you our policy on TC39 is when we implement a new feature in JavaScript, we want to get it out, usually behind a compatibility flag in a browser so that people can try it. But I think everyone's preferred method of doing this is through transpilers. So with JavaScript, we have it a little bit easier. Sometimes in the browser world, partly actually because we don't have web components, it's difficult for people to do this in userland. But thanks to things like transpilers, for the most part, developers can try out these features without us having to introduce them into the browser. Usually we would only go to, I think, the step of introducing them in the browser where a transpiler isn't good enough. Something like Object Observe, for example, where it's in Chrome behind an experimental flag, so folks can try it out, and that just wouldn't be possible with a polyfill in any practical way.
Yeah, I'm sorry, go ahead.
I was just going to say, since we bring up transpilers, just really quickly for anybody that may not actually be familiar with what they are, is that, so people have probably heard of Tracer, I guess is really the granddaddy of them at the moment, and Babel is the new hotness. But all they do is they let you write, the point behind them is to let you write the next version of JavaScript, whatever. So you can use JavaScript classes, and they get transpiled down into something that the current browsers can understand. For example, classes, you have your constructor, and then all of your methods get turned into just a normal constructor function, and prototypes the way that you know it now. So just a way for you to be able to write things for tomorrow, right now, I guess. But on the point of transpilers, to both of you guys, do you think that they make it better? Do they make it easier to start? It's definitely easier to start playing with some of these things. Does they make it better for the growth of some of these standards, because it's probably easier. It's easier in some cases to transpile some of these things rather than, you brought up object.observe that doesn't work, but it's probably easier for the people that maintain these transpilers to throw a feature in than it is for the browser vendors to actually get it in. So are they good for continuing the growth of ES6 and ES7, ECMA, whatever?
I think it's fair to say that there has been a tremendously virtuous cycle between transpilers and the committee and the standardization effort. I think it's really exploded transpilers, letting us take our ideas, test them out in the field in a low-risk way. For a long time, Mozilla was trying to ship features that were sort of, what they thought might be JavaScript next, and the reality is nobody used them because it just wasn't practical to do so. There's not a lot of developers clamoring to go out and try, some nightly build and try out a feature that they have no real possibility of using in their job for, say, 7 years. That really wasn't a model that worked very well, but they were certainly trying. Transpilers works phenomenally well. We've seen really great adoption on various frameworks. So, Angular is really moving big times towards TypeScript, which of course does in addition to adding types to JavaScript, does allow for you to use a lot of ES6 and even ES 2015 and ES 2016 features. So, I think it's been an absolutely positive development, incredibly positive development. And I think, if anything, it's going to push us to be to move faster. And I do want to comment on that year naming. I used to work at Microsoft, and I promise I had nothing to do with this, though, despite that. But I think the intention, regardless of whether I like the name or not, the intention, it's important for the community to understand, is that, we're very sensitive to the fact that ES 2015 took a long time. On a personal note, I'd rather get the web's programming language right. Frankly, I don't think you make big mistakes in the web's programming language, so I would rather wait 10 more years. Not that this is going to happen, the spec has shipped, but I'd rather wait 10 more years than make a big fat mistake in the world's biggest programming language. And so that's my personal opinion. That's not representing the committee, but I think what we definitely can do better is we can break the language up into smaller features and ship, frankly, in the agile way that developers work today, right? The agile way that they expect. And so that's the idea behind the feature train model, where, look, we've got stages of maturity for every JavaScript feature, and if you make it through those stages of maturity to the end, at the year mark, we will ship you. And so that's our attempt, really, to be more reactive to developers' needs and act like, any software development project, really, nowadays.
That's very, very cool. I like the way that you phrased it. So now, AJ. So there are some. So far, these are all the things that we so far are very, very positive about ES6 moving forward. You're pretty well known as a skeptic of ES6.
Well, I wouldn't say that I'm super well known as a skeptic, but I certainly am a skeptic. I want to address that. First, I want to say, am I pronouncing right? Jafar?
Yeah, that's close enough.
Okay.
I'm used to every possible pronunciation. You can't offend me.
Okay, but I want to say it right. Is it Jafar, Jafar?
Jafar.
Jafar. Okay, Jafar. So recently, I watched some of your conference talks. One was from NGConf, the Binding to the Cloud with Falcor. Mm-hmm. And then another one was Asynchronous Programming in Netflix, which was at Scale 2014. And so, I really see the value of where you're coming from and the direction that you want to take things and how it solves, real problems. But the reason that I'm a skeptic of ES6 is I feel like we're introducing more complexity when what we need to focus on is reducing complexity. Now, instead of one way to declare a variable, there's 4 ways to declare a variable. Now, instead of, I really think promises were absolutely needed because we needed one standard way to handle that asynchronous mess because we need functions to be composable, and they weren't until we had promises.
Right.
But now, there's 4 different ways to handle asynchronous programming with await and generators, and I just feel like every time I see a talk on ES6, to me, it looks like the average developer in the room, their eyes are glazing over, and in my mind, I just have this explosion of, oh crap, I'm going to have to teach people how to use this, and why this is better than that, and why all the examples online for the past 15 years do it this way, but now we have to do it this way, and that's already hard enough with getting people on the use strict bus because there were all those fallacies that propagated for so long about how use strict was bad and would break your code that weren't true, except for very minuscule edge cases for the most asinine type of development. And so to me, it's just I'm thinking, oh my gosh, there's so much more. It's going to be more confusing because there's more ways to do the same thing. And what I would really like to see focused on is more like the Crockford style of let's reduce problem areas for current developers. Because I see where we're trying to take C# developers and Ruby developers and Scala developers, and we're trying to make them feel at home in JavaScript. But I think that there are major issues that exist that need to be solved with what we have before we go throwing in all of these things that are nice, but we can do with Transpilers, and we can do with CoffeeScript, and we can do with libraries. So, for example, really simple things like set timeout should throw an error when you put in a string, or at least a string that can't be coerced to a number. simple things like that. Math, I know that this would probably not be solvable because it's a big breaking change, but if you decrement by 0.1, because we have so many APIs where you have to give a value between 0 and 1, and the naive implementation as well, you know, if I want to increase the volume on the sound element, I'm going to increment by 1/10 or by 1/100th. But you do that, and then your program gets in an infinite loop, and that's confusing.
Mm-hmm.
You know, so there's things like that, as well as we keep on adding more stuff to the DOM when we need to be taking it out of the DOM and putting it in JavaScript. We need to be returning JavaScript objects, not returning DOM object. That's one beef I've got with Mozilla right now, is they're adding all these new APIs with Firefox OS. They're adding them all to the DOM and then returning DOM objects that I can't console.log. And so my development process is still just as bad as it was before. So that's where I'm coming from. It's not that I don't think that some of these are good ideas. I think that we just have so many problems that need solving, and we're adding implementations that will be buggy because we're adding them on top of already buggy implementations that we don't have a plan to fix yet. End rant for now.
No, yeah, that's absolutely fine. I mean, again, this is one of the reasons that we wanted to, because right now, for the most part, everybody is very. I'm very excited about ES6. There are some things about it that I like and some things about it that I don't like, but absolutely happy to have another opinion on the matter as well. So everybody that didn't know, this is AJ. But yeah, so we were talking about transpilers, which let us kind of iterate on some of these things faster, because it's easier to get them into the hands of developers because they can still potentially use these things because they're going to get transpiled down into something that can be used in the browser today, which is why things like Babel and Tracer have become so popular. And if you haven't used them, you should definitely go look them up. Tracer is the one that I use, and it's specifically, like, their documentation is very good of how it works, and also the ES6 features it supports, and which ones it supports out of the box, and which ones it supports with a polyfill. So go look at those if you haven't already.
One of the interesting things, though, on that is that Tracer, it has this compilation piece, right? But it also has a runtime, and so a lot of things are done at runtime, which to me would definitely have a performance impact. And I don't know this because I don't use Tracer, except I played around a little bit with it, but I haven't used it in a production app. So I mean, something like Babel or Babel, I don't even know how to pronounce it. It's all at the build level, right? There's no, as far as I can see, and correct me if I'm wrong.
As long as you only use features that it can build. So, for example, classes it can build. Iterators it can't. Iterators require a polyfill, I think, to be used.
There will be some ES6 features that require a runtime. It's not so much that Babel doesn't require a runtime. It's that I think they do, at least when I last looked at it, and apologies to the Tracer guys if I've got this wrong now, they do a better job, I think, of opting into the runtime on a feature by feature basis. But I mean, just that there's some runtime semantics that you can't do without some sort of runtime, and either you basically paste the code in line, which a transpiler can do, but that doesn't really win anything for anybody because, of course, you get a much larger code size if you reuse that feature, or you introduce the runtime. And I think Babel's got a good balance. They introduce the runtime in a very nice, transparent way, and just on a case-by-case basis. But I wanted to come back to AJ's rant and pull it apart a little bit, because there was a lot in there, and definitely some valid points. First thing I want to talk about is, and this I guess this could come off as sort of a dodge, and I could see how somebody in the development community would be frustrated about this, right? First of all, I'm from TC39, right, and I can comment on features like TC39 and that come out of JavaScript, like set timeout isn't really within the purview of JavaScript, and I think this isn't really, these divisions kind of may seem somewhat like dotted lines to developers. I mean, let's face it, you just want the web to be better, right? You want the technologies to work better, you want them to be integrated, and you don't really particularly care about what standards body is responsible for what. But there are good reasons why we have multiple standards bodies. These are big, big problems, and trying to tackle them in one big standards body doesn't work. So my apologies for just talking presumably about the things within my scope of influence, which are JavaScript. And so that means not set timeout, but in the particular case you talked about, the thing that's I think important to talk about from a JavaScript perspective is that you talk about we're adding all these ways of declaring a variable, and frankly now we've got a ton more ways in ES6 of declaring a function, and we will probably continue to add things to the language, and of course taking things away is almost a complete non-starter. We tried to effectively do that with useStrict, and I think it's fair. And once again, I'm speaking for myself here to say that was a failure. We're not really seeing a lot of useStrict out there, and whether that's because of...
I would argue the opposite, but I'll let you continue.
Yeah. I mean, I think transpilers help with that because for new features, of course, we use strict. But in plain old ES5 code, if you quantify the amount of use of useStrict, my recollection is it's pretty low. We're not, like, in terms of sheer coverage numbers, there's not tons of people out there typing those characters on tops of their functions in their files. So I think this policy, one of the nice things about the new syntax is that we end up kind of opting people into useStrict without them having to take an explicit step to opting into useStrict, like within a module syntax, for example. And so really our options are, look, let's stand still. The extremes of our options are let's stand still. Let's not add any new features to JavaScript until we fix all the problems with the web. And I know that's not really your opinion. That's a straw man. But that's an extreme position, and frankly, some people probably hold it. Right? And the other option is, well, we can't take features away from JavaScript, but we can add better ones. And I think if anything, this is adding better parts to JavaScript. And Doug doesn't always agree with what what parts are better and what parts are not. But obviously he advocates, and I think a lot of people advocate, that you can use a subset of a language that's good. And that means, I think, of the choice to stand still and do nothing, and the choice to add better features and then train people to use them and have a gradual migration path. I personally would certainly rather the latter. After having written ES6 code now for quite some time, I certainly have no desire to go back to ES5 code. I think if you look in the broader community also, you don't see, I think you're starting to see some real adoption of ES6 and these features. Obviously, they're resonating with developers. With any new feature, you're going to get the additional complexity of training costs. The nice thing about training costs is that they happen once, and productivity after that point happens every single day, right? And that's on an individual developer basis. And so, personally, given the choice between higher level abstractions and then productivity over the long term, or typing function 13 times, which I did just a few days ago within the context of one function because I was using lambdas in functional programming, I will certainly take the latter. So that's my position on that. That's not necessarily the committee's position, but I think probably pretty close. Probably not a lot of daylight there.
So this is where, first of all, have any of you guys taught at a code camp?
I do quite a bit of teaching, actually. Okay,
so then you've got, you understand where I'm coming from with it's hard to teach people, and my other concern with it's hard to teach people is 99% of people don't get taught. Like, yeah, most of the JavaScript on the web doesn't use useStrict because most of the JavaScript on the web is written by people who aren't programmers and who will never be programmers.
Well, I think a lot of. Go ahead. Sorry.
No, go on.
No, I think you're absolutely right. There's a lot of. It's not just that though. It's the way that we train technology. I worked at several technology training companies, and now it's so much better. Like when I was training, they just wanted you to go and take an 8-hour course, and then you're a JavaScript expert. That's it. You go through the book, and it's like open file. New date, time, blah blah blah. And it's just like spoon-fed to you, and then people have this expectation because of sales and marketing of that whole structure that they're going to be experts at this. And I had the same experience with graphics too, teaching Photoshop and Illustrator. And now you have stuff like Dev Mountain over in Utah, like where you are, that's doing great work, and Hack Reactor, and it's sort of taking away from now you have to go to a 4-year college and spend all this money and learn just the basics of
Java from 15 years ago.
Yeah, which is valuable, but it's not everything you need to know, right?
Yeah.
And the things that you need to know, that core is now taught in some of these alternative schools, and I wish that there was more like that. And the code camps are very fast-paced, and it's hard for them to to do like a curriculum rather than here's a couple of cool things you can do.
Yeah, and I think that the Dev Mountain, like, so I just started teaching there. I had my kind of introductory session where they're like, is this guy good or not? And I was good enough that I'll be teaching again. And looking at their course material, I think that they're really good about not focusing too much on the conventional way, but focusing on the web forward way. Because I've also seen other code camps where, like, they do just want to teach you the way that you're going to see in the examples on the web, so it's more familiar, and I think there's value in that. But personally, it resonates with me to teach people in a way that's going to help them be a better developer overall. And I guess we'll see. Time will tell which methodology is truly better. But that's something that I hope that we get more code camps, no matter which style they follow, and that we get to see more progress there. So I did want to go back to another point too. So somebody mentioned in the comments ASM.js, and I was going to say I think that that's a really good compromise of, we could take something like JavaScript, like TypeScript, and I don't know if there's already a transpiler for this because I haven't really dabbled in the transpilers very much. I didn't enjoy CoffeeScript. I felt like, I feel a little bit better about things like Babel because they are actually making it into JavaScript, so it's not like I'm learning a language that I also have to learn the language it's compiling into. It's still on that same path, and I think that's good. But the idea of ASM.js really appeals to me with something like TypeScript, where I can write in a syntax that's comfortable and familiar. I can have my editor be able to take advantage of tool sets, but then the language itself doesn't have to be brought up to whatever it will one day be in order for me to take real advantage of it and get performance benefits out of it. So I don't know if that's currently possible, but the idea is something that appeals to me. And also another idea is, why not make a new language? I don't know that Dart is necessarily the answer, but I feel like if we say, you know what, these things about JavaScript are just bad and we're never going to fix them, then let's say, we're making JavaScript 2, or we're making this thing that's not compatible. It has to end in .js2 instead of JS. It has to use a script tag with type equals 2 or whatever. But make another language and say, hey, we're just breaking on this, and if you want to take advantage of these features, you can. If you want to use this other one, you can. But then you have two subsets that are simpler subsets instead of one growing large language that you're trying to patch and add new features, but keep bugs for backwards compatibility.
Well, so you can ask the folks over at Python how that worked out. That's not. I think that's a totally reasonable approach that I don't think has been very successful. I think what you're seeing is you can make it your brand new language version, but because the costs of adoption are so high, you end up with two problems, in my opinion. And I think what I want to do is I want to first of all just talk a little bit about the ASM.js thing that you mentioned, which was I think it's not so much that the TypeScript would compile into ASM.js. It's more designed for like a backend for something like C or radically different types of languages, whereas TypeScript you wouldn't get a lot of performance benefits likely from compiling to a very JavaScript-like language into TypeScript. So I just wanted to just set the record straight there. I think more of the point of ASM.js is to be just a backend for radically different types of languages and a very efficient subset of JavaScript that you can implement with just a stack and that type of thing. In terms of transpilers and whether we can create a new language, well, it's very important to clarify that one of the goals of the committee, and JavaScript, I think, is the proverbial big tent language. We have a bigger audience, I think, than most languages out there. And everything, as you said, ranging from a beginner who really doesn't know JavaScript to people coming in from other platforms who think they know JavaScript but don't really know JavaScript, to experts who are doing, I think, some of the most interesting engineering in the field right now, or in the JavaScript community.
I would peg you as one of those guys.
Well,
actually, based on some of your work at Netflix.
There's definitely there's definitely some people doing some phenomenally interesting work, and I think that's some of the most exciting engineering happening. I think it's a great time to be a JavaScript programmer. And the truth is, we're not going to be able to produce a language that keeps all of those people happy, right? Do I judge this language by how quickly people can get ramped up on it? Yeah, that's important. I think one of the strengths of JavaScript has been the fact that you can program it without knowing it. I think often that's said in a sort of a pejorative way, because yes, it leads to a lot of bad code, but you know what? Some of those people get stuff done. They actually build software that works and solves their problems, and I think that's good. We should optimize for that. But as I said, it's a big tent language, and there are people doing serious work in JavaScript, and the limitations of the language right now are hampering those people. And in many senses, the people out there on the edge, they're the ones not using the frameworks but building the frameworks, are actually doing serious work that can eventually, I don't know if I'm coining this, but at least in the sense of technology, there's a trickle-down effect in technology, which is that your beginners can actually start learning React because it's this great framework. But the folks using and building React didn't have to think in terms of the primitives that Brendan Eich thought up in literally 12 days or however long it took him to put together JavaScript. So I think what you're going to continue to see is JavaScript grow, for better or worse. That pace of growth will decline, not so much because there aren't motivated people who want to get new features into JavaScript, but because there's limited syntactic space. JavaScript can only get so big in the sense that every language can only get so big. And so on one hand, there's cause for some calm if you're concerned about JavaScript getting too big. Know that there's an upper bound. We can only stuff so much stuff into this language. But I can tell you that the committee is pretty thoughtful about these things. I would hope that goes without saying. I think everybody on that committee is focused on not just one or two people, but really all of that large tent of JavaScript developers. And of those options that we have, forking, creating a new language, sticking with what we've got just so somebody doesn't have to go through an extra few days of code camp. I don't mean to characterize your opinion, but I think that's really the decisions we have. And frankly, continuing to expand the language and letting people use the features they know. If you don't understand the feature, don't use it. Right? I think it's not as simple as that because people have to read code. But of all those three options, AJ, I will take the one we have right now every time. I think overall it's going to produce the best outcomes. And there's definitely people who are going to get hurt by these changes or it's going to make their life difficult. But I think we've got the global maximum.
So on the big tent idea that you had brought up, that is very true. But I wonder too, because of IoT devices, Raspberry Pis, and you don't really know, like if you have Java, right? You're pretty much guaranteed to know what each runtime would be. And I don't know this for a fact, so correct me if I'm wrong, but it's a lot more standardized. Whereas if you're on a Tesla board or you're on some Raspberry Pi, there's going to be different things that you could use. And you don't have things like on an Arduino board, NPM is going to be very challenging. Things like that. You're going to have a lot of different issues because of that ubiquity, because of that piece of the language. Would you guys agree?
Well, our goal so far is one.js. That's one of our mantras, which is we want JavaScript to be JavaScript. There are a lot of people who have proposed a JavaScript Lite for running on such and such board, but I think so far the committee's perspective is to try and keep JavaScript. And so at least, again, there's the whole other thing, which is the NPM infrastructure and Node, and there's versioning around that. But I think what I'm qualified to really talk about is the JavaScript language, and I don't think we want to splinter that. I think we want to try very hard to keep one.js. But I should mention also, AJ, that if you don't like JavaScript, we are trying to, or if you don't like where it's going, right? We're trying. Part of what we're trying to do, and this goes back to the idea of standards bodies. I think the best standards body puts itself out of business, right? I think what we're trying to do is we're trying to put things into the language which make JavaScript a better compilation target. So if you think JavaScript is a mess, and there are certainly people out there who I think could rightfully say, look, this is an awfully big and complex language. I want to start from scratch. What we want to be is actually a really good compilation target, so you don't have to pay very much performance cost to do that. So even without asm.js, you'll see features like tail call recursion inserted into the language, which is sort of a compromise for that's a feature that a real human being could use in a productive way. But it's also actually a way to replace goto. So you can actually be a pretty efficient build a pretty efficient implementation that targets JavaScript. So we love transpilers from other languages. We want to promote a culture in which people can invent a new language and have it be successful. There is a huge number of hurdles for any new language to be successful, where you define success as broad reach, right, and a lot of tooling support and a big ecosystem. But we still want to lower that barrier as much as possible, and arguably that barrier is as low as it ever has been. And it gets even lower as JavaScript becomes a better compilation target. So my goal, AJ, is to have you be able to use whatever language you want and have it compile into JavaScript if you think you can do better than JavaScript, which I'm sure you can.
Well, I would argue that I can't because I'm not a language designer and I don't really want to be. I do want to take a step back to talking about Raspberry Pi and other environments. That is a topic that is very near and dear to my heart, very important to me because I like JavaScript. It's a language I've devoted a lot of time to learning and understanding the ins and outs of. And I do choose not to use a lot of features because I find, like Intel, they make one type of transistor pretty much, right? Like in hardware manufacturing, you can make the type of transistor that is by default closed, and when you apply current, it opens. Or you can make, it's P-type and N-type, and I don't remember which is which. And the other one is it's default to open, and when you apply current, it closes. But in the manufacturing cost, for most manufacturers, it's actually simpler to just use the one type, and then you can use 3 of them to create the gateway that you need. But and that's how I feel that a lot of my coding pattern is I tend to use fewer features of languages as I become more familiar with them, and just reuse those best parts, right, to be able to create the things that I need, even if another feature kind of would already do it, just because I like that simplicity. I got a little on a tangent there. What I wanted to talk about was the Raspberry Pi stuff. So I develop on Raspberry Pi. I'm actually working on a home cloud system. It's called Walnut. Daply.com is the website, daplie.com. It's not really, it's not product ready yet, so there's not much there. But it's something I'm working on, and I have had a lot of struggle with, like, I want a library that works on Node on a Raspberry Pi as well as on a desktop as well as in a browser. I want it to work on Node version 10 if possible, and also 1.x or 2.x with IOJS, and then in the browser, and there are some serious things that are lacking and make that difficult on a language level. Like, for example, there's no way to handle UTF-8 conversion, so you have to handle it different ways depending on the platform that you're in. And the binary story has gotten a lot better with array buffers, and that's starting to get into IOJS and whatnot. But there's some really basic features that are still missing that make it difficult. And actually, Texas Instruments, their build platform for their ARM processors a few years ago was actually written in JavaScript, right? And so there is this story of like all these different environments, and you want to be able to say like the HTTP call should just work this way because every platform needs it, but we all implement it differently. There's a question like, with some of these things, why does TC39 not step in and say like, hey, this is the function signature that needs to be implemented for an HTTP request, or things like that, where we do get so much variance and it becomes difficult on these various platforms?
Yeah, and I mean, that's a great question. And it's really a question that goes to the heart of what should be in the standard library of JavaScript. And one way of looking at it is I think where the committee is that we're erring on the side of less is more in terms of a standard library. And the main advantage of that is that JavaScript runs in a huge number of places, right? That doesn't mean that and I think one of the things the committee was recently talking about was whether streams, for example, should be standardized. I think we're handling this on sort of a case-by-case basis. I think in terms of the principle here, I want to be careful to articulate a principle that hasn't really been decided on formally by the TC39. But that's my guess. That's my sense of where we are there. Like, we're reluctant to do a lot, really, and I think it's a healthy. I think that's actually healthy for a standards body. And let's find out what happens in userland and let that settle. Maybe the fetch API, which is recently introduced inside of browsers for doing HTTP requests, just makes so much sense and it works so well that it's worth bringing something like that into the standard library of JavaScript. but I think there's an abundance of caution, and I understand that that can be frustrating. But I also want to talk a little bit about what you said earlier, because I mean, there's definitely areas where TC39's dropped the ball. I'm just going to come out and say it. The math stuff, I think we dropped the ball on the last release. We were like different implementations of the engines right now they're kind of bending rules to actually for performance on some of the math, because it's not really well specified how some of the floating point stuff works. And so I think in one meeting in the minutes we were like, well, we should bring in someone who's an expert to tell us about that, because I don't think we felt like there was sufficient expertise on the committee. And you know what? It just didn't get done. And so there's a lot of things on the table to do, but I think part of the effort to be more agile hopefully allows us to address these things more quickly. I don't think anybody wants another 7 years between JavaScript releases, and so I think we are hard on ourselves. I think we need to be hard on ourselves about those areas where we need to be doing more. And I think absolutely the numerics part is one of those areas.
Okay. Well, you're talking about being conservative, and immediately I'm thinking adding 6 new ways to declare a function, standardizing the behavior of set timeout and an HTTP request. Like 100% of people use these, 0% of people were using these. Like,
well, I disagree actually on the way you've characterized that. I think almost all people were using every variant of function we created. They were just writing it exactly the same way. And 6 different things that are actually 6 different patterns that actually mean 6 different things. I don't think the number's exactly 6, but
no,
it's pretty high up there.
Fewer than that. I was just exaggerating.
I mean, they were writing code that was much less descriptive, frankly, about what was going on. I personally hate being a human compiler. If I have to write var self equals this one more time, I am just going to completely lose it, and I never want to do it ever again.
That's my favorite thing. Bind this is my
bind.
I feel like it gives my code a sense of personality when I get to choose, like, do I want it to be called me or that or self?
We have to look for those opportunities for self-expression as developers, don't we? Right? Otherwise, we would have gone to art school. And I mean, I think there's a meta point in there actually, which is that yes, I mean, if you want self-expression, go to art school. I think if everybody's doing this the exact same way and we're seeing this pattern again and again, yeah, throw in another function there. I don't think it hurts that much. I really do think that, yeah, it makes your job as a teacher hard, and that process comes to an end. Are people going to not write JavaScript because there's an extra type of function? Yeah, there's definitely a percentage, right? I think that percentage is overall small. They'll climb over the hill.
Yeah, so I'm not saying that people aren't going to use it. What I was just saying, like, here's a problem that 100% of JavaScript users have, that's existed since JavaScript was implemented as a runtime for Windows 98, versus here's a problem that people have found a valid solution for that works everywhere, versus stuff that doesn't currently work everywhere. That was really my thing. I'm not saying that, like, I do agree that, yes, there are really good things about what we're adding to the language, and I guess, like, I believe that there is a time when that should be added to the language. I guess my main concern is I just feel that time should be after we fix a couple of the things that are already really problematic that people have to deal with on a day-to-day basis, like currently, without transpilers,
I don't think that that's an easy thing either, though, because
definitely not.
One of the great things is the ubiquity, right, where it's everywhere. But one of the things that hurts JavaScript is because it's everywhere. So you can't really break things backwards, right? So like anything new coming in can't break anything old, and so I think that's a big challenge for something like that.
But you correct me if I'm wrong, AJ. I mean, we could add new, better versions of those APIs to the standard library, and you feel more comfortable with that because at least it was addressed? Or would you want us to break existing functionality?
I actually really like the idea of use strict and like a use transitional and a use typed. And I know that from an implementation perspective, I've heard people say that it's just absolutely terrible and it's a nightmare.
I don't think that's the main concern. Frankly, there are not that many browser implementers. And if we thought it was a good idea, that wouldn't be the reason why we didn't do it. I think we just generally don't think it's a good idea.
Yeah,
because it hasn't so far. Yeah.
It's just I can understand that, so I'm not going to be like a proponent of like this is the way we should do it, but to me I kind of like the idea of like use strict is ignore the most common like the most common things that were just bugs, like get rid of them. Use transitional would be like I'm in development mode, so I want some hints and some errors to be thrown. And then like use typed would be if I forgot to optimize something, like it, not only if it's incorrect, but if it's not optimized, like throw an error. Like to me that sounds cool, but from an implementation perspective and an adoption perspective, I don't necessarily think that that's the right way. So to answer your earlier question, like I think I would feel better about adding APIs that solve the problems that we have. Like, you know, well, we added promises, right? So we added this API that solves the problem that we have. I think it would have been cooler if they were like baked into a function so you could return like this dot promise or something like that. But I think that the implementation that was decided on is a good implementation, and it solves the callback problem. And I think if we had other APIs that were just geared more towards like, hey, you've had to do this really weird thing, and I guess that's part of what you're doing with the function stuff is you're saying you had to do this really weird thing, and we're making it simpler. I guess that with the function thing, in my mind, JavaScript is the only event-oriented language. And I think that's an asset to JavaScript, and I think that for me, and this is maybe just I'm that one in a million, for me, understanding it as an event-oriented language, just JavaScript makes sense to me. And when I start thinking about things like await and adding in ways to shim it so it looks more like a multi-threaded language, I just feel icky, like, do I need to mutex lock this, or, you know, so...
So you're not a big fan of the async await proposal, is that what I'm understanding? Because it's yet another function, let's face it.
I don't really understand it, so I shouldn't argue against it too strongly, but when I look at it, when somebody throws it up on, like, here's ES6 ES7 stuff on the projector screen at the meetups, and I see it, I'm like, the first thing that comes to my mind is mutex locking, multi-threaded, like, didn't we try to, wasn't this the purpose of one of the purposes of JavaScript was to get away from this problem, and now we're like, let's introduce this new problem. And correct me, maybe my misunderstanding is completely off.
Your understanding is completely off. But you know what? I think it's important to note that you know, but that's just one of the hazards, once again, of showing new language features to people, right? And especially when people come from threaded languages, right? They may misinterpret what this means. Even coming from C#, you might have a somewhat different idea that these things are like hopping threads, for example. Really, it doesn't introduce any threads at all. It just takes a promise.then and allows you to write it in an imperative way, but really it's just translating into promise.then, nested promise.thens effectively. That's the right mental model to use. So there's no more concurrency. You still got one thread. It's just basically instead of having to force you to arbitrarily split up a logical unit of code into callbacks, simply to resume it from the event loop, you get to write a series of code as a logical block of that code, and let the ceremony of the callback, which is really just a way of working with the event loop, recede into the background. And so it's syntactic sugar, once again, reverse refactoring, the syntactic sugar for what human beings are already doing, the pattern they're continually writing. And I broadly support that. I mean, I think async await's actually been one of the runaway you know, successes in terms of people, you know, in terms of popularity. I think we're seeing a lot of use of it and a lot of excitement about it in the community. And for those of us who do ES 2015, 2016 talks, that's usually, frankly, that's the big finisher. That's where there's a lot of people really excited about that feature. So I think it's broadly understood.
So let me ask a question to see if my understanding is correct or incorrect. Let's say I have multiple HTTP requests going, right? So in reality, in the background, at least in Node, they're running in separate threads. And then they come back into the event loop, and then like when the event loop is ready, they come back. Now we already have this problem in JavaScript where if you have asynchronous functions with a scope, any variable in that scope could be modified. So if you have multiple HTTP requests going, you could have a variable that you're modifying that naively you wouldn't know that it's getting modified twice. that is the issue where I was concerned about await, is that I could be awaiting something and think, oh, because I'm awaiting it right here, the variable up above and the variable down below isn't changing. But in reality, that function that has a click handler in there or a request handler in there could actually fire again, and that same function could fire again, and it could be changing something that's in the upper scope, which is a new type of change that we haven't experienced before because we've become accustomed to a certain pattern of, if I do it this way, my scope won't change on me without me understanding it.
Yeah, well, I think you're stumbling. So to be clear, if you declare a variable local to the async function, then you know it's not going to be modified anywhere else. If you're changing a global variable inside of that async function, right, or variable scoped outside. Yeah, scoped outside of that function. I mean, it certainly can be changed, but that's really no different than today, right? If I create two closures that close over the same variable and I attach them to two different async tasks, and then when the callback comes back, they modify them, there's no extra hazard, right? They both could be modifying it. What I think the real message here is, and I think there's a lot of JavaScript developers that are going to gradually become more and more painfully aware of this, is that pervasive mutation is hard when somebody else is deciding when your code runs, right? If you hand me a callback and then I decide, oh, I'm going to call this now, either synchronously or maybe 10 milliseconds from now, the more you use state to track what's going on in your application, the harder it becomes. Yeah. And so what I think we want to graduate developers up, certainly what here I'm speaking for myself, what I think the optimal place we want to graduate developers to, now that they've moved, I think, from callbacks and they're largely moving to things like promises, is to move even further away from mutation and basically try and structure programs where you're declaratively building a flow, basically more towards something like what they do in functional programming, where you're effectively not using a big piece of state to track what's going on, but you're actually, does that make sense?
Yeah, that actually kind of almost makes me a convert. So like that explanation and that understanding really helped me to assuage some of my fears, because that was very clear, and I understand it a lot better now than I have before, and I feel more confident that it could be an avenue to reduce errors rather than what I feared of an avenue to create more.
Yeah, I think sometimes when you look at what the committee's doing, you have to take a long view in the sense sometimes, because what we're doing often is we're putting features in place, often primitives like promises, for example. This is a great example of what we've done. We put features like primitives like promises in place in one release, fully with the intention of then finishing out the story by adding syntax. So once we've figured out the right idiom to tackle a problem, and maybe that's promises, for example, for asynchronous programming, then later on in a version, just because we want to get things out the door, we can add syntax to make that really idiot-proof and make it very, very easy for developers to use those things correctly. And so the nice thing about JavaScript is that we're developing the next version of the spec concurrently with the current version of the spec. And so that allows us to apply a level of foresight and make broad sweeping changes rather than just sort of in this language just sort of unguided evolution, right? We can do intelligent design instead of unguided evolution and add some features now and then worry about how they work with new features later on. So I think the async function is actually a great example of that process of concurrent evolution of the spec in action. I'm really excited about it. You're going to see that in play with a couple other features as well.
Okay. Well, I hope that you eventually solve the UTF-8 to binary conversion problem. Please put that on your list. But
we'll be watching the ES summaries to see what you're doing.
Gotcha. So the vote has been cast. I hear you.
So we've talked a lot about different features and specifics of ES6 and what it is, and I think everyone's got a really good grasp of this. This is a really good conversation, and you guys have great viewpoints, whether opposing or whether agreeing on it. So this is awesome stuff. Thank you guys. The thing too that I think a lot of us want to know is some of the best practices and the frameworks that are out there now. They're very new. They're very green, right? One of the favorite ones of mine that I've seen out there that's pretty cool. I think I haven't built anything production worthy with it because it's still in alpha. Is Aurelia, and we had Rob Eisenberg on, and one of the things I loved about it was it's so simple. It's very down to, I guess, this overused term, but closer to the metal, right, where you're not having too much abstraction, and it's very pluggable and modular. Would you guys agree with that, or do you think that there's better solutions out there currently with frameworks?
I have to plead ignorance on this one. I'm not familiar with Aurelia. I'm interested. One of the things, the hazards of being in the JavaScript world, and it's a great thing, is there's just so much innovation going on that I can't possibly stay on top of all of it. But I'm definitely going to check it out after this podcast. How about you, AJ? Are you familiar?
No. Like I was saying before, I have not joined the ES6 boat yet. I just when it's native in JavaScript and it's gained more popularity, like browsers are using it and it's implemented. I mean, it's already a lot's implemented in Node, but when it's a little bit more there, I think I'll be using more of the features. But I just compilation steps and stuff. I'm a pansy.
So you don't have a build step? Is that accurate? You don't already have a build step?
So I do have build steps, but I find that I don't like them, and so I try to minimize what goes on. And I find that it's more difficult for other people to get set up if the build step's too complicated. And I mean, I'm sure we've all had that experience where you're using grunt or gulp, and so you're like, oh, it's really easy to get started with my project, just npm install, and then magic happens, and then you npm install, and it's like, wow, that's strange. I don't remember having 400 megabytes of dependencies, but you do. Like, so run this hello world with 400 megabytes of grunt plugins.
Right. But well, allow me to play devil's advocate. So I think most of us now assume that any non-trivial JavaScript has a build step, which is what makes transpilers such a slight incremental cost. Mm-hmm. And more to the point about the size, if we're talking Node, which I think we probably are, right? And so then there's two questions. One, are those dev dependencies, right? Are they just build steps that go away? And two, even if they're not, who cares? Last time I checked, disk space was pretty cheap. If it's not a runtime performance issue.
Oh no. The problem is when you're in a room full of people on Wi-Fi and you're like, here, this is going to take about 30 seconds because you're in your room with Google Fiber all day, and then you go to the conference or the meetup, and then it turns out like, or we wait 15 minutes. That's
bandwidth and platform, right?
Yeah, or Raspberry Pi. Oh my goodness, you want to install one single Bower component on Raspberry Pi, and you're sitting there waiting for literally 3 minutes for the smallest thing, because it's got a. So I do tend to try to make my build process very light, and I don't necessarily have like a great story for it yet, but hopefully I'll get there. But that's
another episode though, right?
Yeah, I'm sorry, I don't want to get into that.
Sorry,
we'll bring you on for another episode for that, though.
And there's build times are a thing, right? Development matters. When you're doing build times, as soon as they start creeping up over more than 5, 6, 7, 8, 9 seconds, there starts to be a real, a real issue, I think, for rapid development. So I don't mean to trivialize the cost of build steps.
Yeah, on frameworks too, with like Koa, for instance, just talking of Node. I mean, everything is with the is it generators? Sorry.
Generators.
So it's generator. I always get the names confused, but generators, and it's sort of like almost forced on you to do that type of best practice, and whether it's a best practice or not, who knows? So, I mean, that's another example of a server-side framework per se.
Honestly, I think that Koa does a good job. Like we had one of those guys on JavaScript Jabber a while ago, and it makes more sense than Express. I still use Express. I still hold to some of my tenets and beliefs, but I think that Koa is really well implemented from what I've seen.
And I should jump in there and mention that the pattern that Koa is using, where you're yielding promises effectively, and those are getting resolved, that is basically just what async await is sugar for. So
I know.
You're familiar with
I know.
Okay, gotcha. Okay.
I'm a hypocrite, just like everyone else on the planet. Okay, I don't deny hypocrisy.
I just want to make sure it's not a gotcha.
One of the great things you said in one of your, I think it was on the .NET Rocks podcast, you were talking about async await, Jafar, and you had mentioned that now you can have these for loops, or for of even maybe, that, and maybe I'm wrong, maybe I heard you wrong, but now you can have these where you get much more accurate iterations inside of the async await. So it's like even more powerful with the way you explained it, at least.
Depends on what you mean when you say accurate iterations. I think the benefit of the for of loop, which is introduced in iterator, is just one of those things removes the boilerplate. It would have been, had we not introduced that syntax, it would have been incredibly cumbersome and common pattern. And so that's all for of does. It just pulls down an iterator and then calls next on it until the next returns that little Boolean false in the iteration result. So that's, I mean, it's not really that big a story, I would say, the for of. I talked a little bit on the .NET Rocks though about for on, which I don't know if we have time to talk about today, but it's more about how can you iterate, how can you do something that looks like iteration? How can you basically for loop over the output of a WebSocket, for example, or for loop over the output of an event? That to me is a very interesting idea. So you know that's one thing we're proposing potentially for an upcoming version of JavaScript.
What was that?
That was the one that I was thinking of.
Was that also what you were talking about with the asynchronous programming in Netflix?
Yeah, so that would be, think about that as syntactic sugar for consuming observables. And for those of you who've seen my talk there, right? And I mean, it really comes from the notion that iteration and observation we now know are duals. And when I say duals, what I mean is it's one turned inside out. If I iterate, right? Let's say AJ, you're the iterable, and I want to get data from you, right? And you're an array and you're an iterable. So play along with me here. We're going to play iterator and iteratee. So I ask you for an iterator, and then I pull next one at a time from that iterator, and I keep getting values. Thank you. Yes. So I say next, and you throw that to me. Excellent. And then finally you say done. So after that one, you just say, hey, no more data, right? I got no more USB keys for you, right? Exactly. And if we turn that the other way around, right? Now, instead, I hand you a callback, right? And now you decide when you send me values. Like before in the iteration, I'm in control, I'm the consumer. And now in observation, you're in control because you decide when you're going to call my callback. You're effectively iterating me. And so when I say something's dual, what I really mean is that we, at a mathematical level, know that there's a correspondence between these two things. And that begs the question, if these two things are, have the same semantics, meaning you can perform the same operations on them, whether that be mapping or filtering or many of the array methods that we know, like map, filter, reduce, for each, shouldn't the language support them equally? In fact, shouldn't, especially given, as you described, JavaScript as an event-oriented language, shouldn't we maybe privilege observation over iteration? I'm not saying we should. I just think that's an interesting question. Why you would start with iteration in a language where callbacks are how a lot of stuff gets done?
No, I honestly think that if we had the foresight of understanding that JavaScript is this new type of language, that it's event-oriented, we wouldn't have ever had a for construct in the language.
Well, there are good reasons. I mean, there are good reasons to have for loops. There's trade-offs between iteration and observation. Just because they can do the same things doesn't mean they have the same costs to doing the same things. So I wouldn't say that I wouldn't have iteration. I'm not sure I would have started there, though. I think there's definitely some use cases for iteration.
Fantastic. So, so I know we're starting to bump up against our time here a little bit. Yeah. So AJ and Jafar, how can absolutely great conversation. Thank you both very, very much for being here. If people want to get in touch with you, to like if they want to follow up on some things you said here, look at other stuff that you guys are doing, other work you're doing in the community, how can they get in touch?
My Twitter handle is usually how I make first contact with folks. So if you have a question, you can reach out to me on there, or just follow me, and we can. I mean, ES Discuss is the place where the community gives feedback about ECMAScript development, and that's, you can open an issue on there and talk back to us. So I mean, those would be I think the best way of getting in contact with me.
So I'm CoolAJ86 everywhere usernames are sold. So Twitter, Gmail, hot new startup thing. I try to grab them all, and my blog and my YouTube channel have material that you might find interesting. So it's coolaj86.com and then youtube.com/users/coolaj86. I've got a lot of tutorial material and whatnot. And then the two things that I'm working on right now that might be of interest, if you want to get in contact with me, or if you're doing something similar, or want to bounce ideas, I'm working on a home cloud system. The idea being turn the internet into a peer network rather than just this, we throw everything out into the ether where it just gets lost and you can never find your Facebook photos or posts again. And then OAuth 3 is kind of part of that. Is I've taken some of the common ideas of, how do we solve frustrations of OAuth 2, and instead of making a framework for authentication, how do we make a protocol for authentication? And that's on oauth3.org, the start of it.
Awesome. Well, thank you guys again very, very much for coming over. I forgot that I was on the podcast for a second, in an absolutely good way. I mean that in an absolutely good way. Like I was just in there listening, and then I was like, oh yeah, I should probably say something at some point. But no, that's absolutely fantastic. That's honestly why I do it, is to get to hear people much smarter than I am talk about things that I try very hard to grasp an understanding of. So, so again, thank you both very, very much for coming on, and thank you to everybody for listening, watching. And we'll see everybody again.
Thanks a lot for having me.
Yep, no problem.
And I'm glad to be here, and I hope that my ignorance was, I served as, hopefully, all those other people that are ignorant like me hopefully learned something.
No, certainly not.
Representative has spoken.
No, we should talk. We should talk more, AJ. We should talk offline.
Okay, cool. Would love to.
Yeah, this was great, guys. Thank you so much for coming on.
Yeah, absolutely. See you later.
All right.